To help you master the content of stoichiometry and limiting reactants, I thought perhaps we could do one more problem together. I won't elaborate as much on this video as the other one, so this one will go a lot quicker. So here we go. So we have a problem proposed that we have 46.61 grams of calcium chloride react with 10.28 grams of lithium nitride. Questions are the same as before. How many grams of product containing lithium will be produced? What is the limiting reactant? And how many grams of excess reactant will remain? So in all stoichiometry problems, our first step is to write a complete balanced equation. So this is a double replacement reaction. And here's the correct equation. Calcium chloride, lithium nitride is going to form calcium nitride and lithium chloride. Now the question is asking us how many grams of the product containing lithium will be formed. That's referring to this one here. After we've balanced the equation, we don't have any use for this calcium nitride. It's not involved in the problem any longer. We still need to write it down, though, to help us get the correct coefficients for the reaction, but we are not going to use it any further after this step. So the first step is I'm going to calculate how much product of lithium chloride I can produce based on the amount of calcium chlorides available, and I'm going to temporarily ignore the lithium nitride. So here it is all worked out. Converted grams to moles, did the ratio from the equation. Again, the ratio is for every 3 moles of calcium chloride, we're going to produce 6 moles of lithium chloride. And so we will be able to produce 35.61 grams of lithium chloride based on the available calcium chloride that's reacting. So I'm going to put that on hold. We're now going to go back and figure out how much product we can make based on the lithium nitride. So I'm going to go ahead and scroll down, and I have that worked out here. We take the 10.28 grams of lithium nitride, convert to moles, ratio, which from the equation, molar mass lithium chloride, and we can expect to produce 37.53 grams of lithium chloride based on the lithium nitride. So we take a look at this. We're going to either make 35 grams or we're going to make 37 grams. We can't make 37 grams because we don't have enough calcium chloride. So I put an X through this because this is never going to happen. We still have to calculate it so we can come to the conclusion. But once we are finished calculating both the products based on the two reactants, I'm going to eliminate this one. It's never going to happen. So as I stated down here, 35.61 grams of lithium chloride will be produced. 37.53 grams of lithium chloride cannot be produced because there's not enough calcium chloride. Since the amount of lithium chloride that can be produced is controlled by the amount of calcium chloride, then we're going to call calcium chloride the limiting reactant because it is limiting reaction. So to go back and answer the questions that are proposed, question part A, we're going to produce 35.61 grams of chloride, and B was what is a limiting reactant? Well, limiting reactant is calcium chloride. Now we have to go back and we need to address part D. So let me switch screens here. And let's take a look at part D. So how many grams of the excess reactant remain? Well, if you go back to the front page, for the initial problem, we had 46.61 grams of calcium chloride reacting. That's equal to 0.4200 moles. There are 0.4200 moles of calcium chloride reacting. To solve for the amount of excess lithium nitride that remains, a molar ratio must be set up between the moles of the limiting reactant, which is calcium chloride, moles of calcium chloride, and the excess reactant, lithium nitride. We want to know how much lithium nitride we need to react with the 0.4200 moles of calcium chloride. So we started this unit off a couple weeks or last week by doing molar ratios. So the question is, if I have 0.4200 moles of calcium chloride, which is a limiting reactant, reacting, how many moles of lithium nitride do we need? So for every 3 calcium chlorides, we're going to need 2 lithium nitrides. You complete the math, and we need 0.2800 moles of lithium nitride to react with the 0.420 moles of calcium chloride. For this reaction, then, 0.2800 moles of lithium nitride will be consumed. To determine how much excess there is, the amount of lithium nitride that is needed must be subtracted from the amount of lithium nitride that is available. So previously in the problem, it was set up, you can convert 10.28 grams of lithium nitride to moles. 0.2951 moles of lithium nitride is what is available in this reaction. As we talked about before, to figure out the amount that is in excess, we simply take the amount that is available, subtract from it the amount that is needed, and that tells us how many moles of lithium nitride are going to be in excess. The question asks how many grams, so we're just simply going to go ahead and convert moles of lithium nitride to grams, and that is our answer. So to answer part D, 0.526 of lithium nitride will be in excess, and they're going to remain after the reaction is over. That is pretty much it. I hope this helped you. And if you have trouble with the Google Forms 1, 2, and 3, I recommend you come back and watch these videos again.